Our Splunk legal team requires we share the following. As you might expect, we'll be making forward-looking statements about our business and financial performance during the course of this presentation. Those statements are subject to risks and uncertainties that are described in our filings with the SEC. Please refer to the full text of the forward-looking statements slide for further information. We ask that you refrain from audio or video recording or rebroadcasting any of the content.
All right, welcome everyone bright and early this morning to our conf presentation. My name is Jamie Armfield. I'm a Senior Manager at Hannon & Partners, a professional consulting firm in Adelaide, South Australia. And we're going to showcase and demonstrate our Splunk implementation at the Department of Health in South Australia and all the interesting things we've done there.
Morning, my name's Jacqueline Chappell. I'm a consultant with Hannon & Partners, and when I'm working with Splunk at SA Health, I'm the Centre of Excellence Coordinator and more recently the Project Manager for the Splunk implementation there. And I guess if you want to know my real title at Hannon & Partners, I am the Facilitator of Good Times.
And hi everyone, my name is Jordan Trecenti. I'm also a Senior Manager at Hannon & Partners. My job on the Splunk implementation for SA Health was the lead technical resource. My other title when I'm not working is I actually live stream games on Twitch and TikTok, so like and subscribe. So, who here remembers those cringy infomercials? The ones where you're kind of getting secondhand embarrassment, watching someone try to put like a cup or something into a cupboard. Well, I've got some news for you. We're going to do one for you to introduce our topic. So, let's do this. All right. All your users can't log in, you don't know where the problem is, and you're running a hospital.
Customer searches are taking forever, and then the CIO's name appears on your phone.
Found 5 servers running at max CPU and don't know what's ruining the user experience?
Well, have we got the answer for you? Introducing the revolutionary Digital Operations Center, your ultimate savior to the clutches of IT nightmares, obviously powered by Splunk.
So, many of you will be familiar with SOCs and with NOCs and often using different tool sets in each. Well, we had an opportunity to use Splunk as the primary tool set for security and services. And so that gave us an opportunity to create a unified Digital Operations Center, or DOC, which as it turns out is a good name for a health provider where the purpose is to diagnose and cure issues. So today we're going to focus on the service health side of our DOC operations and the Splunk implementation that we put around that. The main job, the reason why the DOC was set up was to prevent incidents, prevent P1 as they call them, incidents which take hospitals offline and are a huge deal. Get on the front page of the newspaper in South Australia. So our job was to help reduce and prevent those incidents. For the first time, they had end-to-end visibility of services that historically were very siloed. And often incidents were not detected until the end user was heavily impacted. So that was our first task. Our second task was to provide specialist triage services. So typically tech bridges would have dozens of people on them and it would take hours to find the root cause of issues. So the refrain now on any tech bridge is, what does Splunk see? It's just reduced enormously the time to triage and find issues. Our third was to set up automated alerting. So when we found high confidence scenarios, we wanted to get the information to the right person as quickly as possible. So we are there to set up automatic alerting and get the information to the person as quickly as we can. Fourth, system status reporting, trying to communicate the state of play to anyone within SA Health. We've set up so many dashboards, some that we're going to show today. And that has been the way we keep everyone up to date with exactly how things are going. And finally, when we started in a 50,000 person organisation, there was one person that had some Splunk skills. And so part of our journey was to find ways to uplift the skills across SA Health and and over time have more and more people get on the platform and use it to its best capability.
Okay, so throughout this session today, we're going to shed light on the components that make up the Digital Operations Centre, the scale that it's running at, the process we use to build it, as well as the challenges we face, and we'll show you a demo of it working, which is going to be pretty cool. So to start us off, let's go through the key components that we use to make up the Digital Operations Centre. So the first one is pretty stock standard, Splunk Core, which I'm sure you're all very familiar with. Our design of Splunk Core, we have 45,000 endpoints pushing data into the system with roughly 3 terabytes of data a day. This organisation, SA Health, it's huge. Splunk Core is our main search head. We have 2 others. The second one is ES. So we use that for our SOC component of the doc, and that's set up with all the great stuff with information from DTEX and also risk-based alerting. The third and the primary component that we use for service monitoring is ITSI. I'm not sure how familiar everyone is with ITSI in the room. If you're not, get a copy of it and start using it. It is an amazing tool. And this helps us track thousands of components across the SA Health network, understanding their dependencies, what looks good, what looks bad, and what makes the systems work well and not. The last component is one you may not have heard of before. It's called two-step synthetic monitoring. So this is a third-party product that has a plug-in to Splunk, and it allows us to run robotic tests of end-user experiences. So it allows us to test web clients, APIs, thick clients, even systems running within Citrix or remote desktop services. So we're able to run tests every 5 minutes across South Australia, simulating exactly what an end user is seeing. So the moment we can see that they have a problem, we know about it. We don't have to wait for them to call up.
So I guess you've heard a little bit about our implementation and how we've set things up, but let's give it a little bit of context. So raise your hand if you've ever been to a hospital. Keep that hand raised if you know where Adelaide, South Australia is. Thought so. All right, so Adelaide is about sort of across and down from Sydney. We're a smaller state in the centre of Australia, but in Australia, the majority of our health system is government funded and run. So lots of public health facilities, lots of ways to access the public health system. Some states follow a centralised model, some follow a decentralised model. In South Australia, we follow that centralised model, and one of the things that we really focus on, and what you hear a little bit more about later, is a system called EMR, or our Electronic Patient Management System. So that's the one patient record system to rule them all. The South Australian government employs approximately 100,000 people, which is a huge proportion of South Australia's employable workforce. 40,000 of those workers are employed by South Australian Health, the South Australian Government Health Agency, meaning approximately 3 out of every 100 South Australians is employed or has an interaction with the public health outcome in some way, shape or form. The monetary investment behind it is significant. 50% of the state's total IT spend is directed towards IT, ops and infrastructure. So what does that all mean? It basically means that we're working with one of the largest and complex organisations in South Australia, servicing 1.8 million customers with 70 sites across South Australia in an area 3 times the size of Nevada. So with that size and complexity comes a lot of challenges. So many challenges. So when we started and we were brought in to implement Splunk for SA Health, we were looking at somewhere in the order of over 1,000 applications with minimal or little or no documentation, and there was a highly complex environment with a lot of legacy systems. There were over 1,000 employees just in the IT area alone, and with all these different states of monitoring, there was a lot of different silos sitting around there, which you've heard already. Our journey to stand up the doc, we faced all of these challenges, and they impacted, I guess, our ability to activate the doc. But what we did is we went back to basics, and we looked at really how we could bring that into BAU within SA Health. For example, when Jordan would join a P1 call or a SEV1 call, there might be 100 different people on that Teams call, all just looking around at each other, wondering what was going on. What we were able to do with our Splunk implementation and standing up the doc was be able to give that whole of service visibility and provide the answers there and then. So this meant that we basically had to manually understand all of the systems and dependencies, and thankfully we had Splunk to help us solve this problem.
So before we get to the demo, we want to just talk about, the process that we used, the pillars that undergirded our implementation approach and methodology. And there were 4 core pillars that we used. One was to implement the use cases across SA Health. We used an agile process, a Scrum methodology, 2 weekly sprints, 3 developers, 1 BA, 1 project manager, and we were able to slowly and surely implement and improve and iterate on our implementation every 2 weeks, which was excellent, because when you go into an organisation with such poor documentation and knowledge about how their systems are working, it's good to be able to iterate and finally get the exact implementation or the way the application looks. The second thing we did was we had to take this complexity into something bite-sized. We came up with a tiered deployment architecture, different types of implementation, and Jordan will talk about that more in a moment, and that really helped us get results more quickly. The third thing was change management. This was an organisation very siloed, and it was very easy for people to lose contact with what the project was doing or not really be on board. So we relentlessly communicated to all areas of the organisation, to all levels. Governance meetings, intranet sites, emails, demo after demo after demo, constant engagement with stakeholders was a key to our success. And finally, we set up a centre of excellence that Jacqueline will talk about more in a moment, where we brought together the best people across the country in our industry to help understand how we could do this, and also to provide the training and skills uplift to the people within SA Health itself.
Thanks, Jeremy.
Okay, my go. All right, so the tiered deployment architecture that Jamie mentioned, this is something that we're very proud of, and it was something we had to come up with to overcome all the challenges that Jacqueline previously spoke about. So we came up with 3 levels: basic, intermediate, and advanced, and I'll go through each of those. So basic monitoring is exactly what it sounds like, basic monitoring. Imagine you have an application, basic front end, middle, back end, maybe a load balancer or something else in between it or at the front of it. Basic monitoring allowed us to use Splunk, because our forwarders already deployed to all of those servers, figure out how the servers were communicating with each other, and in ITSI, set up a quick service tree, and we created 50 or so generic KPIs. So that's the stuff like memory, disk space, CPU, how much network traffic is going through. It also included database, web server, and network connectivity. So basic, this group of generic or templated KPIs, we were able to quickly roll out to any piece of infrastructure or any server or application that we got our hands on. So that meant we could run at about 4 to 5 applications per 2 weeks, spinning those up and getting them into ITSI, creating dashboards, creating alerts, creating all the things we need to bring it under what we call basic monitoring. So we essentially created a plug and play out of the box tool that we could rapidly roll out. Now, on the previous slide where we had the challenges, we talked about having no documentation, and unfortunately there was very little documentation or it was outdated. So we were taking a highly educated guess as to how these systems were hooked up. But from our stakeholder perspective, what this allowed us to do was go to them with the monitoring already in place and say, hey, Mr. Expert, Mr. SME, Mrs. SME, what is this? Is this correct? And most of the time they would say, yes, it's correct, or nah, actually, there's another server that's over here. Can you please add that in? So it made our process of refining that monitoring very quickly. And it took maybe 60 minutes with that stakeholder sitting in there and quickly updating ITSI. So great little process that basic was. So we finished basic very quickly, and then we needed more information because, yeah, monitoring the infrastructure is great. It's good to know your server's up, good to know that its CPU is not maxing out, but that doesn't tell you if the application is performing perfectly. How many times have you had a user ring you up and say, yeah, the application's not working, but the CPU and the rest of the infrastructure is working fine? Turns out it's a problem within the database or within the application layer. So with intermediate, what we did using Splunk as well, we identified all of the Windows services or Unix services, processes, log files, and even data within databases that could help tell us if an application was working good or if it was working bad. So we ingested all that data, figured it all out, got rid of all the noise, and then turned them into KPIs. So for each application, we can have anywhere from probably on average another 10 KPIs for some of the smaller ones. For the bigger applications, up to another 100 KPIs. That would be monitoring log files to say, oh, this user's had a problem. Or maybe it's looking at the response time and saying, that took way too long, trigger an alert, get someone to take a look at it. So intermediate was a game changer. It allowed us to look within the applications. And again, we were able to do this very quickly because we were just using Splunk forwarders, pulling the data in, or using DB Connect, getting data out of the database. So that was great. So by that point, our stakeholders are very happy. They're getting visibility into the physical infrastructure or virtualized infrastructure, and they're getting a look into the inside the application as well as network connectivity, which was another great thing that we had in there. We're able to monitor all the WAN links going from data center to regional hospitals. Remember, we have 70 sites, so there's a lot of network gear to monitor, and we're able to figure out exactly where there might be a problem. And in our demo, we'll show you how that works. So the third tier, advanced. Advanced was limited. It was very special, though. We kept it for our critical applications. So these are the applications that if they go down, patient care is immediately impacted. You can't get your bloods done. You can't get your x-rays done. You can't get through triage. So advanced is where we use ITSI's analytics component, where we can get prediction up to 30 minutes in advance that something may go wrong. And this blew our mind because it allowed us to get 30 minutes in front of an incident, or potential incident in this case, and fix it before it happens. Now, of course, not all the time we get the 30-minute warning, but for the times it has provided us that, it's been, in some cases, probably a lifesaver because people were able to get into the hospital without being interrupted. The second part of advance was two-step synthetics, which I mentioned before. So over, I think it's 10 sites in South Australia of the 70, we've deployed essentially little PCs, nothing too special, that run the SOE, so the standard operating environment of SA Health, and we act as an end user robotically or automatically on those boxes, simulating that end user experience, logging onto the patient system, trying to triage a patient, trying to look up their record, trying to put clinical notes in, exactly as if the user was doing it. There is no difference between the robot doing it and the user because it's literally a mouse moving around and clicking on things. So by putting those boxes in each site, we're able to get timings from each site as well to figure out, is there a network latency or routing problem? Is it affecting the one site? Is it affecting all the sites? The good news is the moment something goes wrong, we have an alert. And that's a lot quicker than a user going, oh crap, now I've got to ring up service desk and tell them there's a problem. So that process for them to ring up can take 10 minutes to half an hour, depending on how busy the line is. Remember, this is a 40,000 person organization. So we're on the front foot straight away, hopefully solving the problem before they can even get onto a service desk agent. So the synthetic monitoring tool is, I've said game changer a few times. It's another game changer. It's amazing. Definitely something to add into your toolkit.
Thanks, George. So sitting underneath all of this is our SA Health Centre of Excellence. So for those of you that may have joined us last year, we shared our journey of bringing the Centre of Excellence to life. And what that is essentially a community of practice that's centred around Splunk at the moment. So basically, this dedicated business unit was designed to drive the adoption of Splunk best practices, improve platform implementation, and increase the pool of skilled Splunk resources across South Australia. 12 months on, and the Centre of Excellence has continued this knowledge-sharing journey through a national cross-jurisdictional forum for the healthcare sector. We've also trained upwards of 160 staff in SA Health and onboarded over 100 users into our SA Health Splunk environment. What we also found is we needed to create our own education documentation to sit alongside and complement the existing Splunk education portal. So what we've done is created our own SharePoint site that has tailored training and documentation to basically guide people through our environment. Through our involvement with SEV1s or P1s, we also found that we needed to basically teach people how to troubleshoot using Splunk, which is a very specialised skill. So what we did is we ran a number of boot camps for our service delivery managers, our application owners, and the service desk people. And basically, we took them through exactly what we would do when we were triaging or investigating an incident. So where we weren't able to proactively prevent that incident, we were going to take everyone through the process on how to fix it and identify the root cause really fast. So from here, what we were able to do is more and more, we found that people, when we were getting on the calls, people were going, well, what can Splunk see? What can Splunk see? And this is where we've been able to provide a huge amount of value through the doc to SA Health and really reduce the duration of incidents and the time to resolve them as well. But that's enough of me talking. I guess we're going to do the show and tell section now.
Could you switch over to the demo?
There we go.
Thank you very much. All right, so we're going to give you a little peek. This is a video of our live environment. We have at various places had to blur out server names and things that were deemed a little sensitive. We wanted to give you an idea of what we've implemented. So we have a lot of dashboards, and this is sort of the dashboard to rule them all. This is our Digital Operations Centre dashboard. We have put it on 75-inch vertical screens, touch screens. There's one in the CIO's office. This sort of tells them exactly, what's up and what isn't at any time. As we said, our main purpose was to prevent P1. So any current incident in the top area there is outlined. Any P1 or P2 from the past 24 hours will be listed there. We have a goal to see how many days since the last P1, so that'll be shown, some statistics on KPIs. Then the next layer underneath, EMR, that's the most critical application within SA Health. That's the patient record system across South Australia. So we actually dedicated a row to that and broke down the service health into some of its core subcomponents, and we also included the two-step stuff there under user experience, so at any time you could see kind of back end and front end how well it's working, and if there is a problem, what part of the application is causing that problem straight away. Then underneath that we listed many of the other critical services that are part of SA Health's portfolio, and a few there that are still to come online, but that really just gives at one glance a huge amount of information to all levels of the organisation, including the CIO. We did get a request to know a little bit more though than just the health score. So underneath this, as you'll see in a moment, we decided to actually list at a KPI level anything that's above normal. We split it out by OS, by database, web, app, all those sort of areas. So you can at a glance see which particular piece of infrastructure is running hot or is doing something unusual, what service it belongs to, and that just gave people more of an idea what the problem might actually be before they've even really delved into Splunk or raised an incident. And then final part of this dashboard at the bottom here was just to provide some other metrics that were seen as necessary, some internet activity, some VPN activity, and offline servers that people might need to know. Now, because this was a touch screen and because that's a lot of KPIs, we decided to take advantage of that. And so, for instance, if you touch one of the panels up above, it will show you the KPIs relevant to it. In this case, at Astra, there is nothing above normal, so everything is running well. But if we go back up to the top, we'll see that DHCP is degraded at the moment, and by touching that, it will then show the particular KPIs that are relevant to that service, and enables you to quickly start to troubleshoot. So this provided a lot more context for people and was seen as a great step forward. Now that's just one of many dashboards that we have done, one for every application, and so we decided to put it all together in a site within Splunk and set up a menu structure that would mean people, even without a lot of Splunk knowledge, could get the information they wanted. We have an overview menu with the one you've just seen, plus a couple of others. And then every application we listed according to its, the letter of the alphabet it starts with. And then within that, in E here, we've got, say, MP, our patient index system, and we have direct links to both the application page itself, direct to the service analyzer in ITSE, and then also direct into some areas like deep dives, which is a really powerful tool within ITSE for really starting to compare where the KPIs are going wrong. And so we did shortcuts directly to deep dive services for app and web and database, and also to logs themselves. So that just really cut down the time. So people who didn't know what index to go to or just where to get at the information quickly for an application could go here in the menu system, and immediately they're up and running, looking at something very specific for their application. We also did some other dashboards for core ICT, for networking, Marvel, our ticketing system, and then some standard menus. The last thing I'll show you in my bit here is just one of our application dashboards. So this one is the one for MP, which is the master patient index for SA Health. And you'll see that here. And so what we did is came up with a format that we could replicate across all the applications. So that made the rollout time really, really quick, where we broke down the service health score into its various operating system, application, network, and database components. Any current incident for that application then is listed underneath in the Marvel section. In this case, there's 2 P4s, an overview of the KPIs and how many might be above normal. In this case, there's 2. And then you see in the next 2 panels, we will list the KPIs that are above normal, and we will list the incidents that are currently open. And so that just means that, again, without a lot of Splunk knowledge, people at all parts of the organisation can see what's happening with my application. Is there an issue? What is the issue likely to be? And that's just been, as Jordan would say, a game changer at SA Health for diagnosing issues. So the next thing we want to show you is the service analyzer, and for that I will pass it on to Jordan.
Cool, thanks Jamie.
Oh, we're almost
As
there.
we wait for our video to
it's a video.
To go across. Still on the demo, sorry, thank you. Excellent. Okay, so what Jamie just showed you was our top level dashboard to rule them all, the doc one, and then a particular application, MP, the patient index. Behind all of that is ITSI. Before I go into a specific part of ITSI for MP, I want to show you the breadth of what we're monitoring. So this is our total service tree. We have over 1,287 services with well over 12,000 KPIs. So in a moment, I will start, yep, here we go. So this, what you're seeing at the moment, is a zoomed out version. Every single one of those dots is a service. It could have 1, it could have 20 KPIs in there. You can see all the lines joining everything together, showing us the dependencies between network links, routers, application servers, databases, and so on. That's only a third of what we predict SA Health is going to need for their entire IT environment. It's a lot. I really hope ITSI can handle another 3,000 services, but we'll get there one day. So what we're filtered on at the moment is the MP specific service analyzer. And the way we've crafted these, so at the top, you can see each grouping of physical location. We call them local health networks. Underneath that, you can see the physical locations. And you can see there's one that's orange and one that's red, the Women's and Children's Hospital on the right. And then below that, we filtered particularly on MP, the patient index. So we can see exactly which sites are using that application. Again, it helps a lot to know which sites use an application because 1,000 or more systems, and it's very different of who uses what. So the way we broke down MP was into an app node, a request node, database node, and an operating system node. We then have the WAN links that service that application. So we know it runs in 3 different data centers. We look at the WAN links to make sure that that data center is up and running properly and we're actually getting connectivity. So it makes it, again, very easy to understand what's happening. The cool part is we can see that Women's and Children's is having a problem, but we know it's not MP because MP is not in a red or orange state. So looking at the operating system node here, we've got our standard set of KPIs, and we're clicking on those. We can see, processor active time. We can see the servers and what they were currently running at. Looking at SQL, we have around 14 SQL KPIs that monitor standard Microsoft. We've also got MySQL and Oracle and all the different flavors of databases out there, and we can monitor exactly what's happening within those instances. So again, what you're seeing, what I've just showed you with OS and MySQL and WAN, that was basic monitoring. So this is just the kind of out-of-the-box templated things that we created with minimal effort, which was great. Where it gets nice and fancy is where we move over to our intermediate level, which is the app and request node. When my video catches up. So in the app node and the request node, this is where we went to that intermediate level. So under app, that's where we pulled out all the Windows services, processes, memory and use for particular processes, anything that would help us determine if the application is running good or running bad. So we can see there was one particular Java memory process that was running a little bit high, nothing really to worry about. And in this one here, this is the request. I'll just pause that for a sec. This is where we pull in log files from the system to determine how fast is it responding. So if I go into the system and look up my own name, is it taking 1 second, 5 seconds, what might it be? So we're able to get those exact metrics and put them into KPIs. So the moment we see something taking more than 10 seconds, probably time to trigger an alert because it shouldn't be taking that long. This system's meant to be very, very fast. All right, moving on to the next one. All right, so what I'm going to show you now is inbuilt into ITSI. So you may be familiar with this. If you click on any entity name in ITSI, it brings this up. I'm not sure if anyone's seen this before, but it's an amazing tool that shows you at a glance the core details of a server, whether it's Windows, Unix, whatever it might be. This is out-of-the-box functionality in ITSI. This screen here is pretty basic. We already had that within our service analyzer, but there's also a number of other dashboards you can see in that drop-down list that again come out the box, but also you can add your own. The one I'm going to show you is Win event logs. So as the monitoring team for the doc, we don't have access to the servers. We can't log into them for security reasons. But we are able to pull all that data into Splunk. And these dashboards allow us to see all the Win event logs in one spot. We don't need to write SPL for it, and we can see what's the most common event, what's the lowest event, anything that stands out, and allows us to, again, quickly troubleshoot what's going on. So next thing I'll show you, in that menu system where we've provided very quick access to things, we created a lot of saved searches because remember, we have 1,000 people in IT. We don't expect all of them to be SPL experts or Splunk experts. So what we created, and sorry, we had to blur everything out for security reasons, but at the top there, you'll see we've pre-populated the index, and we've also created a function that automatically pulls all the server names for that particular application MP. So it just looks it up from ITSI and chucks it into the search. So our users don't have to worry about SPL because we don't expect them to all be Splunkers. And if they can write SPL, that's just an added bonus. So we created these saved searches for all the common things, Windows event logs, any particular application logs, database logs, even sys logs, which was, yeah, pretty cool. So our users can come in here, keep typing in so they can look for the keyword error, which will bring back all the Win event logs with the keyword error in there. So again, makes it very quick access to this information. Over to you, Jacqueline.
Thanks, George. More and more, we were presented with lots of different use cases that we could provide solutions for. So what you can see here is a dashboard that we've created for our change requests that come through. So what we've listed is the description of the change, the request number, who's assigned to that change, any CIs that are related to it, and also the entities that sit alongside, which is blurred off to the right. So this was a way that we could basically see if a change had been made and if it had any bearing on an incident or investigation at that time. The next view that we provided was around our firewall changes. So again, when we're looking at if there's been an issue or a change or an incident, we can go through this firewall change, and it's listing all the rule names, the source and destination, port and application, the action, and the comments. So again, as we scroll through here, that you can see there's a few firewall changes that happen at SA Health. So it's good to keep on top of them and have a tool to easily search them for teams. Moving over to our checkpoint logs. So this is a really, really good example of the KISS principle. So this is such a simple search, but what it allows someone in the service desk to do or a member of the doc is basically see if there's if someone's hitting the firewall when there's a connection issue. So at this point in time, before this dashboard existed, someone would call the service desk and then they'd have to contact someone in the network area to see where the problem was. This dashboard means that there's one central source for that information and it can be accessed by anyone that can access Splunk. Moving across, we've also created a number of different views, including when we're looking at our Microsoft environment. So we created an Office 365 overview. So again, we've got all those key metrics at the top, looking at all the different email, Teams, SharePoint, etc. We can view on that single pane of glass, looking at the open incidents within SA Health, any KPIs above threshold, and also any Office 365 advisories. So you've got that one single source of information there, which is great. The last one that I will touch on, which has been really quite amazing for, again, such a simple view, is printing. Now, so for those that have been listening today, I guess the key thing that we're looking to do is improve patient outcomes. If we look at printing, we have 20,000 printers across SA Health. If you think about a clinician who needs a blood sample that needs to be taken, if they are waiting 10 minutes for that label to print, that's 10 minutes that they can't provide that care and improve that patient outcome. So what the guys found that they could do was basically bring in all those logs from the printers and create a really high-level overview for printer statistics, but also somewhere in regional South Australia, one of the team can see if there's a door open on a printer or if it's out of paper. So very, very powerful tool that Splunk has been able to help us create and something that we can access. So when you think about it, you might be able to actually give this dashboard to an orderly in a hospital and they can go around and access and make sure that the printers are running as they should, which allows doctors, nurses, etc. to get on with their job and not worry about printing. So I guess that's me. That's it for the demo.
That's it for the demo. Okay, so we just showed you a lot of stuff. So I want to bring it back to why we showed you all that stuff. So the first thing we showed you was the doc dashboard, the one dashboard to rule them all. That's the one we have on 75-inch TVs in portrait mode that we put in the CIO's office, which was either a good or a bad idea, depends on the day. But it means that executives can see at a glance when something is going wrong. The problem for us, it means they're calling us the moment anything goes red. Good or bad. Anyway, the second thing we showed you were the application-specific dashboards. So we created these for every app we brought under monitoring in a templated view, which meant we could bring these, create these in a very short time, a few days, which was amazing. That included creating everything in ITSI. I then showed you ITSI with over 10,000 KPIs, all their thresholding, all the weightings, all their dependencies, and that really awesome entity view so you can see exactly what's happening on a host without having to log on to it or, again, run any SPL. Because we designed all of this because you're in a P1. It's broken. Something has gone wrong. You need quick access. You don't want to be stuffing around with SPL. Unless you're a Splunk expert, then great, go for it. But again, a lot of our users weren't. So quick access was our core requirement, which then brings me to the saved searches. That menu system has been our probably most powerful thing we could create, because it means someone just logs into Splunk and goes applications, MP, I want the logs for the database, I want the logs for Windows, I want the logs for WebSphere, and straight away it is there. So pretty cool. And then we showed you the other systems. Big, complex environment, lots of dependencies. Printing, Office 365, the ITSM, the firewall, all have a link in to how a system is performing. So we try to add in all those other systems as well to provide that full visibility. So that's all the stuff, and that's how it all fits together.
And how's it all working? Well, there it is in action. The doc's been in operation for about 6 months now. In its first 3 weeks, it already got some fame and glory by preventing 3 P1 incidents, and it's reducing detection time by over 75% at the moment, and triage time by certainly over 50%. And its ability, actually one of the interesting ones, SA Health never knew exactly when to call an incident as resolved because they'd have to put out calls to the end users across the state to find out if everything's working right, so the bridges would stay open and open and open. And just being able to actually definitively say through Splunk, especially through our synthetic monitoring and that kind of thing, just being able to say, yes, everything's up and working normally meant that they could terminate tech bridges so much more quickly than they used to. It's just broken down silos across the organisation. People have visibility into systems they never had visibility before, especially the CIO. And it's also solved problems that were plaguing teams for months. Problems that were slightly interdependent with other areas they just never could get to the bottom of. Suddenly, within a few days, these long-standing issues were starting to be resolved one by one, which was, Jordan, would you say it changed the game?
It was a game changer.
It was the game changer, yeah. So, we really appreciate your time today. We're happy to take questions, but thank you for listening to us. Thank you.
Thank you.
We'll ask that anyone has questions if they just go up to the microphone, please.
Yes.
My CIO, I use the phrase game changer all the time, and my CIO makes fun of me for it constantly. I had a couple of questions. One, how are you building and maintaining the service trees and entities inside of ITSI? Do you have a CMDB that you're tapping into? And how dynamic are you maintaining the service trees?
So they're not very dynamic at the moment. That dashboard that Jacqueline showed you that had all of the Marvel RFC, so all the change requests from the ITSM system, that's a daily process that our doc runs. So every morning they'll look at what changes are coming up and they'll determine, is that change going to impact the monitoring or the ITSI service tree? They'll mark it as, nah, it's all good, or yes, we need to make a change, add in a new dependency, remove a server, whatever it might be. We find that we've got this so well templated, we can usually make those changes within half an hour, depending on what it is. There are some changes though, for example, they are moving EMR, the big application, to the cloud. There's hundreds of servers, so when that happens, that's probably a few weeks worth of work and testing and so on. But for the general applications, when there is a change, it's usually within half an hour or so that we can get it updated. But it is a manual process through ITSI. Anything that is large, like the 100 servers that we're going to have to migrate over, we'll be using the CSV import function within ITSI. If you can get that template really well understood, it does save a lot of time. For example, I imported 200 different services for DHCP, DNS, and Active Directory through the CSV import function within ITSI, probably in about an hour. Took a few guys to get it right, but it was a lot quicker than doing it manually.
Another question, across the enterprise architecture, do you have any microservices?
Sorry, what was that?
Do you have any microservices across the enterprise architecture yet?
No, not in this environment. It's all very monolithic applications.
Okay, and have you explored anything with observability yet?
No, not yet.
Cool, thank you.
Thank you.
So you showed a pretty extensive list of saved searches that you have linked out to, as well as a really cool dashboard about network traffic or network blocks. I'm definitely going to use that idea. What's the process been like for deciding what to include, or kind of predicting what your users might want to without making them know SPL?
Yeah, that's a great question. So a lot of that did come from our own experience. A lot of us in our organization have worked operational roles in IT before, so we did draw on our own knowledge. However, we did spend that hour that I mentioned when we went through the intermediate level with the end users. We asked them what is key to know if your application is working well or not. So if they said, oh, I log on to this server and I look at this particular log file, then we would make sure that was a saved search. So we did have a set of questioning in our business analysis sessions to pull that information out of them. But typically we had the standard set of Windows, SQL, and web logs, and then anything specific to the application. Now, sometimes the users will come to us and say, hey, could you please put that log in? And we'll chuck it in. At the end of the day, this is a system for them. So we want to make sure that we give them ownership of that menu system as much as possible.
Cool, thanks.
Cool, thank you.
Yes.
Hey, first of all, great presentation. Do you mind sharing if you are using adaptive thresholding and anomaly detection in the ITSI? Like the AI and ML features of the ITSI?
Oh, the AI features, the predictive
like the
analytics?
adaptive thresholding and anomaly detection.
Yeah, so we are using the predictive analytics a little bit for understanding when the right amount of users are on or off, so if there's a particular network outage. So that's what's giving us the 30 minutes of predictability within some of our KPIs.
Oh, got it. Okay. And the other question is like, how big is your indexer cluster, considering like you're running these many KPIs and these many services in there? ITSSO, right?
How big is our index cluster? That is a good idea. I'm looking at one of our tech experts like that. How many numbers are we holding up? 30? 30.
Thank you.
No problem.
Hi, thanks for presenting. I had a question about like triage and how do you really determine who or how to notify when something's going wrong?
Yeah.
So folks aren't really looking at the dashboard at all times, you know?
Yeah. So SA Health came with a lot of existing procedures that we're able to draw on. So what we created in ITSI was a lookup that essentially had, if it's this application, we know it goes to this group. If it's this application, but it's the infrastructure, it goes to this group. 1,000 people in IT, sometimes it's hard to figure out. By creating this very simple lookup, by grabbing their existing information, we were able to reduce how long it took for a service desk call to get to the end person to start making a fix. Sometimes it'll take an hour to get through service desk to the right person. Now when something goes critical, we're able to immediately identify who it needs to go to, because let's say it's SQL, all right, alert gets triggered, it's going to go straight to the DBAs as opposed to any other triaging process. But we did draw on SA Health's existing processes. If a company didn't have those processes, what we would do would run a series of workshops with everyone and start assigning roles and responsibilities, going, okay, you're the infrastructure person, you're responsible for X, Y, and Z, you're a database person, this is what you're responsible with. Hope that answered your question.
Yeah, that's great. How exactly do you notify folks as well? Like, do you determine like if it's an email versus a call versus like a...
Oh, how do we send it to them?
Yeah.
So it depends on what it is. On the day-to-day, so usually between 9 and 5, everything goes through Microsoft Teams. So if they're, let's say there's an applications group, they have an MS Teams channel and they get an alert that goes through there. If it's something that we have high confidence about, we send it straight to the ticketing system as well as the Microsoft Teams message. If it is super critical and high confidence, like we've just lost all the internet or we've just lost the patient system, SMSs. They will go out to all the core people and they'll be able to stand up a tech bridge straight away. So we do have various communication methods depending on how confident we are on the alert and how important the alert might be.
Thank you, very helpful.
Cool. Thank you.
I'll just point out that our whole Hannon & Partners team for the Splunk implementation is here. So if you see these guys at the front or us out and about, feel free to chat to us more. Thank you very much for joining us.
Thank you.
Thank you.